What is up, guys? This is Physics 2211 Lab 4 Oscillations by Rocco Garcia. So, first we have the table of contents, which we will be doing the introduction, computational analysis of motion, results, and what does it mean. First, some key concepts Newton's second law of motion. This is how we're going to be updating velocity and position for the spring. Then, gravitational force. Um, Gravitational force is going to have a constant pull on the spring as it oscillates, so that'll be factoring in. Then we have the spring force and energy formulas, and this is how we're going to see that this object is able to oscillate. And in the experiment, we're going to be comparing the predicted motion and the observed motion of the mass and plot the energy changes. This is my tracker data. All of this data that computed from me putting in every single point gave me a list of data, and this is how we're going to be making our models. And here's some excerpts from my code. The ball's mass, its initial position and velocity, g, spring constant, relaxed mass, relaxed length of the spring, and then some other position and energy formulas. Then we're factoring in the force of gravity, and then we have our momentum principle here, and then we're updating L and L hat as it iterates. And here is a snippet of my tracker, of my code using the tracker data, and you can see that it is oscillating, and that yellow line, we'll see what it means later. This is in the X position, and this is tracking Y position. Closer look on the results, and here's my predicted versus observed. And obviously some possible sources of error could be rounding errors after each iteration and possibly rounding of G. And what does it mean? The energy principle is satisfied because, as we can see, the change of energy is 0 throughout the entire oscillation period. So zero change in energy means no work is done on the system. And as we can see, whenever potential energy is at its max, kinetic energy is at its minimum. And this is what makes it oscillate. And computing this time period, to solve this, we could use, we could average the time constant t, and like throughout every period in the oscillation, and that'll give us an average value, and it'll get us closer to the value it's supposed to be. And that was it. Thank you for listening.